Okay, so we've seen now a basic Lambda expression. So let's now look at some Lambda expressions which use different functional interfaces. So if we're only passing in one parameter, then we don't have to use parentheses. We only use parentheses if either we're passing multiple parameters, in which case we have those parameters comma separated, like A, B, C, D, that kind of thing, or in the case where we have no parameters whatsoever. So we always have to have something there in that case, because otherwise it's not parsable by the compiler. However, if we just have one parameter which is passed, then we don't have to use the parentheses. So let's do this now. Let's pass the name into the Lambda expression. So let's get rid of that, and we'll get rid of those two. We'll just have a simple one-liner Lambda expression. And you can see at this point that doesn't work. So let's hover over and see why. It says incompatible parameter types in Lambda expression. Wrong number of parameters, expected 0, found 1. And the reason for that is because the compiler is checking this Lambda expression here, the function descriptor of that, which it knows takes a string as an input parameter. And the reason it knows it's a string, by the way, is because of the context within which it's used here. So the compiler can infer the type because we're concatenating strings here. However, that function descriptor, which takes a string, isn't compatible with the runnable. And that's because runnable, if you look in here, it doesn't take a string. So if we can modify that and put in string, which we can't because it says file is read-only, then it would fix it. So let's do something kind of similar. Let's just copy that. So we copy that runnable interface back into here. Let's call it something else. Let's call it a string runnable. It's an awful name, but just for the sake of demo. And delete the Java doc, we don't need that. So if I copy string runnable here we get the same error as we got before, but now you'll see if I do this and update that method in the functional interface to take a string, that error has now gone. And the error's gone now because indeed string runnable, its function descriptor, takes a string. And the Lambda expression also takes a string, which is here, is its name. Of course, now we've got an issue here. And the issue here, where it's saying run string in string runnable cannot be applied to, and those empty parentheses, what they're saying is you can't invoke this method now without passing in something in. And that's because it does indeed have to take an input parameter. We need to pass in the name. So now if I type in Matt, everything compiles. And that's because we're now passing in the string parameter when we invoke the function, which is held in that Lambda expression, and everything matches nicely. The function descriptors match, method signatures match, the parameters we're passing in match, everything is good. So now if I do Control R to run, then we get the same effect as before. So we get the same effect now. It still says hello Matt, but it's just we've got it in a different way. We've kind of refactored things slightly, or reworked them rather, such that we've adapted the functional interface to meet the needs of the Lambda expression. In other words, the Lambda expression took an input parameter, so we adapted the functional interface to take that parameter. This also shows you, by the way, how to create a functional interface. You can see here we've got this at functional interface annotation. This declares it to be a functional interface, and we've got this abstract method here. So a functional interface in general only ever has one abstract method, a so-called single abstract method, and optionally you can pass in this functional interface annotation on the interface itself. A functional interface doesn't need that annotation, but it's just there such that the compiler can catch any errors. So for example, if I start to add a method here, like so, string do greeting, then we'll get this compile error here when it says multiple non-overriding abstract methods found in the interface. And what that means basically is don't put more than one single abstract method in a functional interface, otherwise it's not a functional interface. So get rid of that, that's all fine. So in this video we've seen how we can take an existing Lambda expression, refactor it to pass in an input parameter, and create or adapt an existing functional interface to provide a matching target type for that Lambda expression. And as you can see, it's not too difficult to do, and as you become more confident with functional interfaces and Lambda expressions, you'll find that it's quite easy to either use existing functional interfaces from the java.util.function package, or create your own functional interfaces like we've seen here.